Somewhere beneath the surface of Mars right now there is an ocean. Not a memory of one, not a dry basin where one used to be, but actual water, enormous quantities of it, hidden in the cold rock beneath the dust. We have been calling Mars the dry planet for a century, sending robots to poke at its barren red surface, and the whole time it has been holding a secret directly under their wheels. 3.5 billion years ago, that buried water broke loose just once, in a single catastrophic flood that carved a scar across the planet longer than a country. The rest of it never left. It is still down there, frozen, waiting. So how does a world end up burying its own sea? And what else might be hidden in the dark along with it? Get cozy and settle in. Subscribe if you have not already, and stay with us, because what Mars buried beneath its surface may be the most important thing we ever dig up off another world. Let's dive in. Part 1. The Image. I want you to start with a single picture. It came down from orbit just days ago, and it was not painted by an artist, and it was not dreamed up by a computer. A real spacecraft circling another planet right now turned its camera toward the ground and sent this home. What it shows is a scar, a long pale wound carved straight into the skin of an entire world, running for roughly 1,300 kilometers across the middle of Mars. To give that a shape you can hold in your mind, that is about the length of Italy, from the mountains in the north all the way down to the toe of the boot, gouged into the rock in one continuous line, and it was not cut slowly. Something tore it open in a single catastrophic event, 3.5 billion years ago, and the planet has been carrying the mark ever since. These new images came from the European Space Agency, captured by an orbiter that has been quietly mapping Mars from above since late 2003. They are the clearest look we have ever gotten at this particular wound, and they arrive with a strange kind of patience, because the thing they show us has been sitting there, unchanged, for longer than there has been complex life on Earth. When these images were taken, when the light bounced off that ancient channel and into the camera, it was bouncing off a surface that was already 3.5 billion years old. You're looking at a photograph of a moment of violence that happened before the first multicellular creatures ever crawled across the floor of our own oceans. And here is the part that I find almost impossible to let go of. A scar implies a wound, and a wound implies that something was alive enough to be hurt. We do not say a rock has a scar. We say a body has a scar, a living thing that took damage and kept going. So the very first question this picture asks, before we know anything else, is a quiet and unsettling one. What kind of world gets a scar? What was Mars doing 3.5 billion years ago that left a mark this size? Because the answer, it turns out, is not what most of us were ever taught about the red planet. The Mars in this picture was not the dry, dead, rust-coloured desert we think we know. It was something else entirely, and the wound running across its face is the single best clue we have to what it used to be. I want to be honest with you about what we're doing tonight, because it shapes everything that follows. We are going to treat this one image as a doorway. On the surface, it is a story about a flood, a channel, a piece of Martian geography with a name most people have never heard. But if you follow it down, if you let the channel pull you back through time the way the water once pulled rock and ice downhill, it opens into something much larger. It opens into the story of how a planet lives and how a planet dies, and what gets left behind when the dying is done. Mars is trying to tell us something with this scar. We're only just now learning how to listen. It is worth pausing on the machine that brought us this picture, because it is part of why the moment feels the way it does. The spacecraft that took it has been orbiting Mars for more than 2 decades, circling the planet over and over, carrying a camera built to see the ground in 3 dimensions, to capture not just the flat shape of a feature, but its depth and relief, the way your 2 eyes let you see that a thing is near or far. So when it looked down at this channel, it did not just photograph a pale line on a map. It measured the shape of the wound, how far down it cuts, how its walls rise, how the floor of it falls away toward the north. We are not guessing at the 3rd dimension. We are seeing it, and that is what makes these particular images the clearest look we have ever had at this feature. Clear enough that you can almost feel yourself standing on the rim, looking down into a valley carved by a force no human has ever witnessed. I keep coming back to the number 1,300 kilometers because numbers that large tend to slide right off the mind, and this one deserves to stick. If you started at one end of this channel and tried to walk its length at a steady pace, day after day, it would take you the better part of 2 months of continuous walking to reach the other end, and the whole way you would be walking inside a scar that was cut in a matter of hours. That is the part that does not fit in your head at first. The thing took less than a day to form. It has lasted 3.5 billion years. The ratio between how fast it was made and how long it has endured is almost absurd, like a signature scrawled in a single second that outlives the civilization that wrote it by an eternity. Mars wrote this in an afternoon, and has been holding it up for us ever since, and we almost did not look. For most of the history of Mars exploration, our attention went to the obvious targets, the canyons, the volcanoes, the polar caps, the places that look dramatic from a distance. A long winding channel running off the equatorial highlands toward the northern lowlands did not scream for attention the way a continent-sized canyon did. It took years of patient mapping, of better cameras and sharper eyes in orbit, before features like this one were recognized for what they truly were, before someone looked at that pale line and understood they were looking at the path of the largest kind of flood the solar system has ever produced. The clue was sitting there the whole time, in plain sight, on a planet we had been photographing for decades. We just had to grow into the ability to see it. That is a recurring lesson in the study of Mars, and it is worth holding on to. The planet does not hide its secrets behind a locked door. It leaves them out in the open, written across its surface, and waits, sometimes for decades, for us to finally understand what we are looking at. And it forces a quiet correction to almost everything most of us grew up believing about this planet. For generations, the popular picture of Mars has been the dead world, the cold red rock, the rusty desert that never had a chance, the dry and lifeless neighbour we send robots to poke at. That picture is not wrong about Mars today, but it is badly, profoundly incomplete about the Mars that was, because a dead rock does not get a scar like this. A scar like this requires water, and not a little of it, and not for a moment. It requires an entire planet's worth of water, held and hidden and then released in fury. So the image is not just a pretty picture from another world, it is a contradiction of the story we were told, and the contradiction is the whole point. So settle in, and let me show you what we found. Because beneath that channel, beneath the dust and the cold and the silence, Mars has been hiding something enormous, and to understand what it is, and why it matters, and why a wound this old should make the hair on the back of your neck stand up, we have to go back. We have to go back to a Mars you would not recognize. A Mars that was, for a few 100 million years, one of the most promising places in the entire solar system. The question is not only what tore this channel open. The question is, what was here before it did? And what, if anything, was watching when it happened? That last part is not a throwaway line, and I do not want you to treat it as one, because it will come back to haunt this entire story. When something this violent happens on a planet, our instinct is to ask what caused it and what it left behind. But there is a stranger, quieter question hiding underneath, and it only makes sense once you understand what Mars used to be. The question is whether the world this happened to was empty, whether the water that erupted across the surface was just water, or whether it carried something with it, whether, on a planet that had oceans and rivers and rain for hundreds of millions of years, there was ever anything alive to notice that the end had come. We are not ready to answer that yet. We have to earn it by walking the whole length of this story first. But I want you to hold the question from the very start, because everything we are about to uncover is, in the end, pointing toward it. Part 2. A different Mars. Picture Mars about 4 billion years ago, and then throw away almost everything you think it looked like. There is no rust-coloured emptiness here, no thin pink sky, no frozen silence. Instead, imagine standing on a shoreline. The air is thicker than the wisp of gas that wraps the planet today, thick enough to hold warmth, thick enough that liquid water can sit on the surface without instantly boiling away or freezing solid. The temperatures are mild enough, at least in places and at least for stretches of time, that water flows. And it does not just trickle, it pools, it spreads, it gathers into lakes, and along the low northern half of the planet, the evidence suggests it gathered into something far bigger than a lake. It gathered into an ocean. Scientists did not arrive at this picture overnight, and they did not arrive at it on faith. They built it the slow way, piece by piece, by reading the rock. The clues are scattered all across the Martian surface for anyone who knows how to look. There are ancient river deltas, the fan-shaped deposits that form only where a flowing river slows down and drops its sediment into a standing body of water. There are dried lake beds, flat-floored basins ringed with the chemistry of evaporation. There are branching valley networks that look, from orbit, almost exactly like the drainage patterns of rivers on Earth, and there are minerals, certain clays and certain salts that simply do not form unless liquid water is present to make them. You cannot fake those minerals, water has a signature, and Mars is covered in it. When you put all of that together, you get a planet that was wet, and not briefly. The window we are talking about may have lasted hundreds of millions of years. Let that number settle for a moment, because it is easy to skim past. Hundreds of millions of years is not a passing season of good weather. It is longer than the entire age of the dinosaurs on Earth. It is enough time for a world to develop weather, to cycle water from sea to sky and back again, to build coastlines and carve valleys and lay down sediment in patient layers. For that stretch of time, Mars was not a frozen rock orbiting at the edge of the habitable zone. It may have been one of the gentlest, most inviting places anywhere near the Sun, and that is the detail that changes how you feel standing on that imagined shore, because 4 billion years ago the Earth was barely getting started. Our own planet was a young, restless place, still being pounded by impacts, its own oceans only recently settled. If you had been some visitor passing through the early solar system, looking for somewhere that might amount to something, you would not have automatically picked Earth. You might just as easily have looked at Mars. 2 worlds, side by side, both wet, both warm enough, both holding the same basic promise. For a while, they were running the same race. 2 planets, 2 oceans, 2 chances. I want to dwell on the evidence a little longer, because it is the foundation under everything else, and it is genuinely remarkable how much of it there is. Consider the clays. Certain clay minerals form only when rock sits in contact with liquid water for a long time, weathering slowly the way granite weathers into soil on a rainy Earth hillside. We find those clays on Mars, in places, in quantities that imply not a brief splash but sustained, patient contact between rock and water across long spans of time. Consider the salts and sulfates, the kind of minerals left behind when a body of water slowly evaporates, concentrating its dissolved chemistry into deposits. We find those too. Consider the shape of the valleys, the way they branch and join like the veins of a leaf, the way rivers branch on Earth as smaller streams feed into larger ones. That branching is the fingerprint of rainfall and runoff, of water falling across a region and gathering itself into channels. Each of these clues, on its own, might be argued away. All of them together, pointing in the same direction, are very hard to explain with anything but a wet world. There is a wrinkle in this story that makes it stranger and, to my mind, more wonderful, and scientists have a name for it. They call it the faint young sun problem. 4 billion years ago, the sun was not as bright as it is today. A young star like ours burns dimmer in its youth and slowly brightens over billions of years, which means early Mars, already farther from the sun than Earth, was receiving even less warmth than its cold distance would suggest today. By the simplest math, Mars 4 billion years ago should have been frozen solid, a ball of ice from pole to pole, and yet the rock insists it was not. The rock insists there was liquid water, flowing and pooling and carving. Something kept early Mars warm enough, a thicker atmosphere trapping heat, volcanic gases blanketing the world, some combination of effects we are still working to fully understand. The planet was warmer than it had any right to be, and that warmth, however it was achieved, is what opened the window. For a few 100 million years, against the odds, against a dim sun and a cold orbit, Mars was a world where water could live. We know how the race ended. We are here, on the blue one, and Mars is a desert. But 4 billion years ago, that ending was not written yet. And if you had stood on that Martian shore, with the small pale sun hanging in a sky that may have been hazy and blue-tinted, you would have had no way of knowing that this world was already on a clock, that somewhere beneath your feet, in the machinery of the planet itself, a process had begun that would, slowly and then all at once, take every drop of this water away. The water you were looking at had somewhere it needed to be, and it was running out of time to get there. There is something almost unbearably poignant in that, when you really picture it. Imagine standing on that ancient shore on a calm day, the water gentle, the air breathable enough, the world around you quiet and alive, and everything about the scene telling you that this is a place with a future. Nothing in that moment would warn you otherwise. The doom of this world is not in the sky or the sea where you could see it. It is buried at the center of the planet in a core that is cooling a little too fast, in an engine that is already beginning to slow. The catastrophe is not coming from outside. It is built into the planet itself, into its size, into the simple physics of how a small world holds its heat. And so the shore looks eternal and is already dying, and there is no one to tell, and nothing to be done, and the water keeps lapping at the sand as if it had all the time in the world. That is the story underneath the scar. Not just that Mars had water, but that Mars lost it, and that the losing left a record we can still read. It is worth sitting for a moment with just how habitable this version of Mars might have been, because the word habitable does a lot of quiet work. We are not only saying water existed, we are saying that for a long stretch of time, the conditions on the surface of Mars were inside the narrow band that allows a planet to be hospitable. The temperature was warm enough, at least seasonally and at least in places, for liquid water rather than ice. The pressure was high enough that water could pool rather than boiling instantly into vapour. There was an atmosphere overhead to trap warmth and to shield the ground. There was energy, from sunlight and from the planet's own warm interior. And there was chemistry, the minerals and elements that water could dissolve and carry and combine. Every one of those is a box that has to be checked for a world to be more than a frozen rock. And early Mars appears to have checked them all, at the same time, for a very long time. That is not a small thing. By the standards we use to judge whether a world could host life, early Mars was not marginal, it was genuinely promising, and that is what makes the next part of the story land the way it does. Because everything I just described, the warmth, the pressure, the air, the water, the chemistry, was temporary. Every single one of those favourable conditions was already living on borrowed time. The planet that checked all the boxes was, in the same moment, quietly beginning to fail them, one by one, in an order and on a timescale that no one standing on that ancient shore could possibly have perceived. The world was perfect and doomed at once, and the two facts were not in tension. They were the same fact, seen from different ends of time. So the next question is the obvious one, and it is the one that takes us underground. If the oceans were here, and the rivers, and the rain, then where did all of it go? Part 3. The water that went underground. The thing about water is that it never simply disappears. It is one of the most stubborn substances in the universe. You can freeze it, boil it, hide it, split it apart into its component atoms, but it does not just vanish into nothing. So when a planet has oceans and then, sometime later, does not, the water has to have gone somewhere. The first instinct most people have is that it froze, or that it escaped into space, and both of those things did happen, and we will get to them. But there is a third destination, and it is the one that matters most for the story we are telling, and it is the one hiding inside the title of this whole journey. A great deal of Mars's water did not leave. It went down, it went underground, and the water had nowhere left to go but into the dark. Here is how that happens. As Mars began to change, as the surface grew colder and the air grew thinner, liquid water at the surface became harder and harder to sustain. But a planet is not just a surface. A planet is a body with a thick crust of rock, and that rock is not solid all the way through. It is porous. It is shot through with cracks and pores and spaces, like an enormous sponge made of stone. And just as water on Earth seeps down through soil and rock to fill underground aquifers, the water on Mars seeped downward too, retreating from a surface that was turning hostile, pooling and freezing in the cold rock beneath. Some of it froze into solid ice, locked into the ground like mortar between bricks. But some of it, deeper down, where the warmth of the planet's interior still reached, stayed liquid, trapped, pressurized, sealed beneath a growing lid of frozen ground. I want you to really hold this image, because it is the center of everything. Imagine reservoirs of water, enormous ones, buried hundreds of meters or more beneath the Martian surface. Above them, a thick ceiling of frozen rock and ice like the lid on a pot. Below and around them, the slow heat of the planet keeping at least some of that water liquid, and the water itself sitting there under pressure with nowhere to escape to. The surface had closed over it. The cold had sealed it in. For millions upon millions of years this water simply waited, held down in the dark, a hidden sea pressed flat beneath the skin of a dying world. This is the enormous thing Mars has been hiding. Not a structure, not a machine, not some buried object. Water. A planet's worth of it, withdrawn from the sky and locked away underground. And I want you to notice how strange that answer is, compared to what the title might make you expect. When you hear that a planet is hiding something enormous beneath its surface, your mind reaches for something dramatic, a buried machine, a hidden structure, some object that does not belong. The truth is stranger than any of that, and quieter, and in its own way more profound. The enormous thing Mars is hiding is not a thing at all. It is an absence made physical. It is the planet's missing ocean, the seas and rivers and rain of an entire world, all of it pulled down out of sight and pressed into the rock. The most enormous thing a planet can hide is not some alien object. It is its own lost self, the wet and living world it used to be, folded away into the dark where the cold could not finish it off. Mars is hiding its own past beneath its surface, and the channel we started with is the one place that past briefly broke back through. To really picture this, you have to let go of the idea that the ground beneath your feet is solid in the way it feels solid. Rock looks impenetrable, but on the scale of a whole planet, the crust is more like a sponge made of stone. It is threaded through with cracks, with pores, with tiny spaces between grains, and all of those spaces can hold water. On Earth, this is not exotic at all. A huge fraction of the fresh water on our planet is not in lakes or rivers at all. It is underground, held in the rock beneath us, in what we call aquifers, and we drill wells to reach it. When you draw water from a well, you are pulling up water that has soaked down into the porous rock and gathered there. Now take that ordinary process and run it on a dying world. As the surface of Mars turned hostile, the water did exactly what water does. It soaked downward, draining out of the cold, thinning surface into the warmer, sheltered rock below, gathering in the pores and cracks of the Martian crust the way water gathers in an aquifer beneath a desert on Earth. And here the cold did something important. Near the surface, where the rock was frozen, that downward soaking water froze too, building up a thick layer of ground that was permanently frozen solid, a frozen shell wrapping the upper crust of the planet. Scientists call this frozen layer the cryosphere, and it acted like a lid, a seal, a cap of frozen ground sitting over the warmer rock below. So you end up with a stack, a structure, that is the whole key to this story. At the top, the cold, dead surface. Below that, a thick layer of permanently frozen ground, the cryosphere sealing everything in. And below that, where the planet's own interior heat still reached, liquid water, trapped beneath the frozen lid, unable to rise through it, unable to escape, building pressure as more water joined it from below and the heat kept it liquid and expanding. A buried, pressurized sea capped by ice, waiting in the dark. Hold that structure in your mind because it is the loaded gun in this story, and the rest of it is about the moment the trigger gets pulled. The quantities involved are difficult to take in. We are not talking about an underground pond. The water that was withdrawn from the surface of Mars, the oceans and rivers and rain of an entire world, did not shrink when it went underground. It was still a planet's worth of water, now compressed into the rock, spread through enormous regions of the crust, in volumes that beg a comparison. When one of these reservoirs later broke open and flooded out, the flood it produced was, as we will see, possibly the largest in the history of the solar system, and that flood came from just one reservoir, one breaking point, one wound. That tells you how much was down there. The amount of water Mars hid beneath its surface was not a remnant or a trickle. It was the sea itself, relocated into the dark. Now, there is something you need to understand about water held under pressure, because it explains what happens next, and it is the reason this story does not end with the water simply sitting quietly forever. Pressurized water is not at peace. It is held in place only by the strength of whatever is containing it. Think of a garden hose with your thumb over the end, the pressure building behind your thumb, the water straining to get out. Think of a shaken bottle, the contents pushing against the cap. The frozen ceiling over those Martian reservoirs was the thumb, the cap, the lid. And lids do not last forever. Over long enough timescales, the pressure beneath keeps building, the heat from below keeps working, and the balance grows more and more precarious. The water wants out. It has wanted out for a very long time. All it needs is a weakness. All it needs is a crack. I want to be clear about the timescales here, because they are part of what makes this so haunting. We are not talking about water that hid for a few centuries and then burst out. We are talking about water that may have been sealed underground for hundreds of millions, even billions of years. Sit with that. There were buried reservoirs on Mars that held their water in the dark for longer than animals have existed on Earth, longer than there have been trees, longer than there have been bones. Through all of that time, while life on our planet went from single cells to fish, to forests, to the first creatures that would one day look up and wonder about Mars, that water simply sat pressurized and patient and unseen beneath the frozen ground of a dying world. The stillness of it is almost unbearable to imagine. An entire sea held in suspension, in total darkness, in perfect silence, for a span of time that dwarfs the whole story of life as we know it. And the only thing that ever interrupted that stillness was the rare, violent moment when a seal finally failed and a piece of that buried sea came roaring back into the light. And this is where the geography becomes the story, because scientists have a very good idea of where one of these buried reservoirs gave way, and they have a name for the place. It is a highland region near the Martian equator called Xanthi Terra, a broad, elevated plateau of old, cratered rock. From orbit, much of it looks like ordinary Martian highland, the kind of ancient, beaten terrain you would expect on a 4-billion-year-old surface. But at one particular spot, the ground does something that ordinary geology does not explain. It breaks, it collapses, it shatters into a chaos of tilted blocks and sunken pits, as if the floor were pulled out from under it. And right at that broken place the great scar begins. The channel does not start in the middle of nowhere. It starts exactly where the ground caved in. So to understand the wound, we have to understand the breaking. We have to stand at Xanthi Terra at the moment the lid finally failed and watch what a buried sea does when it is finally suddenly set free. Part 4. Xanthi Terra and the Breaking Point. Let me set the scene properly at Xanthi Terra, because the longer you sit with it, the more tension it holds. Picture a plateau of ancient rock near the Martian equator, maybe a little warmer than the freezing wastes near the poles, sitting on top of one of those buried pressurized reservoirs of water and ice. Everything looks stable. From the outside, nothing is happening. The surface is quiet, cold, ordinary, but underneath the situation is anything but quiet. The water down there has been building pressure for ages. The heat from the planet's interior has been keeping the lower layers liquid, expanding them, pushing them against their frozen ceiling. The whole arrangement is a slow-motion standoff between the water that wants out and the rock that is holding it in. And standoffs like that always end. The only question is what tips them over the edge. There are two main suspects, and scientists genuinely debate which one did the deed here, or whether it was some combination of both. The first suspect is an impact. Mars, like every world in the solar system, has been hit by asteroids and comets across its entire history, and some of those impacts were enormous. Now imagine a sizable meteorite slamming into Xanthi Terra, punching down through the crust, drilling straight through that frozen ceiling and into the pressurized reservoir beneath. In an instant you have opened the bottle. You have given the water the crack it has been waiting millions of years to find. The impact does not just make a crater, it uncorks a buried sea. The second suspect is fire from below rather than a blow from above. Mars was volcanically active, and not in a small way. It hosts the largest volcanoes in the solar system, mountains that dwarf anything on Earth. Where there is volcanism, there is heat moving through the crust, magma rising, the ground warming from beneath. Now imagine that heat reaching up toward one of those frozen reservoirs and beginning to melt the ice that was holding everything sealed. The lid, which had held for so long precisely because it was frozen solid, starts to soften, starts to weaken, and once it weakens past a certain point, it can no longer hold back the pressure underneath. The seal fails not from a sudden punch, but from a slow, fatal warming. Either way, impact or volcano, the result is the same. The containment breaks, and once it breaks, there is no putting it back. There is no force on a dying Mars that can refreeze that lid in time, no power that can shove the water back down and reseal it. Once the path to the surface is open, and the pressure has somewhere to go, the reservoir empties itself completely, the way a punctured tank empties, the way a breached dam empties, the way anything held under pressure empties the moment its container fails. The release is a one-way door. The buried sea that took millions of years to gather and pressurize is given back to the surface in a span of hours and days, and there is no second act, no slow refilling, at least not from that same broken chamber. Whatever water was in there is gone, spent in a single catastrophic withdrawal, leaving behind an emptied space underground and a fresh scar across the face of the world. It is worth noticing, too, that the trigger and the water are almost incidental to each other, which is part of what makes the event feel so inevitable in hindsight. The water did not need a special rare kind of trigger. It needed any trigger at all. A reservoir that loaded and pressurized for that long, capped by a lid being warmed from below and bombarded from above, was a system that could be set off by a sufficiently large impact, by enough volcanic heat, by a strong enough quake, by any number of ordinary planetary events. On a world as geologically busy as early Mars, with its enormous volcanoes and its steady rain of asteroids, the question was never whether one of these reservoirs would fail. The question was only which one would fail first, and when. The catastrophe was not waiting for something extraordinary to happen. It was waiting for almost anything to happen, and on a planet almost anything eventually does. It is worth lingering on the volcanoes, because Mars does not do volcanism in a small way, and the scale of it makes the second scenario vivid. This is the planet that hosts the largest volcano in the solar system, a mountain so enormous that if you stood at its base you would not even be able to see its peak, because the summit would be lost above the curve of the horizon, and the slope would rise so gradually that it would feel less like a mountain and more like the whole world tilting upward. There is an entire region of Mars, an enormous volcanic bulge that swelled up over billions of years as molten rock pushed toward the surface from below. Where you have that much volcanic machinery, you have heat moving through the crust on a grand scale, and you have the perfect engine for melting the frozen seal over a buried reservoir. The ice that had held for hundreds of millions of years, frozen and strong, only needed to be warmed past a certain point to lose its grip. Volcanic heat could do that patiently, from below, softening the lid until the day it could no longer hold. The impact scenario has its own kind of terrible elegance. Mars sits closer to the asteroid belt than Earth does, and across billions of years it has been struck again and again by rock falling out of the sky. Most impacts just make craters, but imagine the unlucky geometry of a large impact landing directly over a buried pressurized reservoir. The incoming rock punches down through the cold crust, through the frozen cryosphere, and breaches the sealed chamber underneath in an instant. It is the difference between a slow leak and a sudden puncture. One moment the reservoir is sealed and stable, the next it has a hole driven straight into it from above, and everything that was held under pressure now has an open path to the surface. We may never know for certain which of these triggers fired at this particular spot, the slow warming or the sudden blow. But the beauty of it, from the standpoint of understanding the planet, is that it almost does not matter. The reservoir was loaded. Sooner or later, by fire or by impact, something was always going to set it off. I find it genuinely difficult to overstate how much energy was sitting in that buried system, waiting. We are not talking about a spring bubbling up out of the ground. We are talking about a reservoir under enormous pressure, capped by rock, holding a quantity of water that would have measured in the billions, possibly trillions of tons. All of that was held in a kind of fragile equilibrium for an unimaginable length of time, and all of it was poised to release the moment the lid failed. To put a frame around the numbers, consider that scientists talk about these floods in terms of billions, and possibly trillions, of tons of water released. A ton of water is a cube about the size of a small kitchen table. 1 billion of them is already past the point where the mind can picture it, and we may be talking about 1,000 times more than that, all of it driven out under pressure through a single broken place in the crust. There is simply no event in ordinary human experience to compare it to. The largest dam failures in our own history, disasters that drowned valleys and killed thousands, released a tiny fraction of this. We are talking about a release on the scale of a planet performed by a planet using water a planet had been storing for an age. The reservoir at Xanthi Terra was not like any reservoir a human ever built. It was a feature of a world, and when it failed at the scale of a world. It is the planetary equivalent of a dam, except no one built this dam and no one was watching it, and the reservoir behind it had been filling and pressurizing for millions of years. When a dam like that goes, it does not leak. It does not crack and weep a little water. It fails completely, and everything behind it comes through at once. There is a human comparison that makes the danger of these buried reservoirs feel real. and it comes from our own experience with the ground beneath our feet. On Earth, we know what happens when you remove the support from underneath the surface. When too much water or oil is pumped out of the ground beneath a city, the land above can sink, sometimes by meters, sometimes suddenly. When underground caverns dissolve in soluble rock, the ground above can collapse without warning into a sinkhole, swallowing roads and houses in seconds. The principle is simple and unforgiving. A surface is only as stable as whatever is holding it up from below. Now take that principle and scale it up to a buried reservoir of water and ice the size of a region, sealed under pressure beneath a frozen lid, on a planet whose interior is slowly warming that lid from beneath, and whose sky is occasionally dropping asteroids onto it from above. The collapse, when it came, was not a freak event. It was the most predictable thing in the world. It was a structure that had been engineered by nothing but physics to fail, and the ground above it knew, in the only way ground can know. Because before the water ever reached the surface in its full fury, the support beneath that surface was already vanishing. When you pull the water and the ice out from under a slab of rock, you take away the very thing holding that slab up. The floor loses its foundation, and a floor that has lost its foundation does only one thing: it falls. So the very first sign that something had gone catastrophically wrong at Xanthi Terra was not a flood. It was the ground itself beginning to collapse. To see what that looked like, I want to put you there, standing on that doomed surface in the final moments before it gave way. Hold on to something, because the floor of this world is about to drop out from under you. Part 5. The Collapse. Stand with me on the surface of Xanthi Terra, 3.5 billion years ago, in the last quiet minute before everything changes. The ground beneath your boots is cold, ancient rock, cratered and still. The sky overhead is dim, the small sun casting long, weak shadows across a plain that has not changed in 100 million years. It is silent here, the kind of silence only a thin atmosphere can make, where sound has almost nothing to travel through. You could stand here and believe, completely, that nothing on this plane would ever move, and then you feel it. A tremor, soft at first, rising up through the soles of your feet. A hairline crack opens across the ground in front of you, and then another, and the cracks begin to race outward faster than you can follow them. The plane is no longer solid. The plane is coming apart. The first block goes with a sound you feel more than hear, a low shudder that runs through the whole region. An entire slab of crust, wide enough to swallow a city, tilts and drops as the support beneath it simply ceases to exist. Dust leaps up from 1,000 new fractures at once, hanging strangely in the thin air, falling slower than it would on Earth. Around you, the ground is breaking into pieces, enormous angular blocks of rock heaving and sinking at wild angles, some pitching up to form instant ridges, others plunging downward into pits that did not exist seconds ago. The flat plain is converting itself in real time into a shattered maze. You try to move, and there is nowhere to move to. The ground that was solid a moment ago is now a shifting field of breaking blocks, each one tilting on its own, the gaps between them opening into trenches that drop away into darkness. The dust thickens the dim light into a haze. The small sun overhead becomes a pale smear. Underfoot, the rock keeps lurching, settling, dropping again, as the support beneath the whole region continues to fail in waves, each new collapse triggering the next. There is no safe direction, because the danger is not coming from somewhere. The danger is the ground itself, everywhere, all at once, ceasing to be something you can stand on. And through it all, you feel a new vibration rising up from below, lower and steadier than the grinding of the rock, a sound that is not the ground breaking, but something coming up through the breaks. The water has found the cracks. The water is climbing. You're standing inside the collapse of a world, and the world is not asking your permission. Try to hold the strangeness of the motion, because it is unlike anything we experience on Earth. In the thin Martian air, the dust thrown up by the collapse does not billow and settle the way it would here. It hangs. It drifts upward in slow, ghostly sheets, and falls back with a dreamlike laziness, because the gravity is weaker and there is almost no air to push against. So the scene around you is violent and gentle at once. Enormous blocks of crust dropping with terrible force, and above them a slow, silent snow of pale dust sifting down through a sky that can barely carry a sound. You would feel the ground heave through your boots far more than you would hear it. The catastrophe is happening in something close to silence, the low noise of it travelling through the rock rather than the air, a world coming apart in a hush. There is something almost worse about that quiet. A disaster on Earth roars. This one barely whispers, and somehow that makes it more total, as if the planet is too far gone to even make the sound of its own breaking. And the collapse does not happen in one neat place and then stop. It spreads. As one block drops and pulls the support from the rock beside it, that neighbour goes too, and the failure races outward across the region in a chain, square kilometre after square kilometre of ancient surface foundering, as the water beneath it withdraws and the floor loses its foundation. What had been, minutes ago, a flat and stable plain becomes a sprawling field of wreckage stretching past the horizon, an entire district of a planet dropping into the space the water is vacating. You're not watching a sinkhole, you're watching a region the size of a small country come apart at once. This is the moment that geologists looking at the aftermath 3.5 billion years later gave one of the most fitting names in all of planetary science. They call it chaotic terrain, and honestly the name does not oversell it. When you look at these regions from orbit today, you see exactly what was created in that violent minute, frozen and preserved across the eons, huge blocks of rock tilted at impossible angles, long trenches cutting between them, flat-topped mesas rising at random from a fractured floor, like the broken remains of the original surface left standing where everything around them fell. It looks, from above, as if some enormous hand reached down and crumpled the planet like paper, then walked away and left the wreckage where it lay. And that, in a sense, is precisely what happened. The hand was the water, pulled out from below. The crumpling was the ground collapsing into the space the water left behind. But the collapse, as overwhelming as it is to stand inside, is only the opening act, because the same event that drops the ground is the event that frees the water. As that ceiling of rock and ice shatters and falls, the pressurized reservoir beneath it is suddenly, catastrophically exposed. The thumb has come off the hose, the cap has blown off the bottle. Millions of years of contained pressure now have a way out, and the way out is straight up through the broken ground where you are still somehow standing. The trembling underfoot changes character. It is no longer the dry grinding of collapsing rock. It is something deeper and wetter and far more frightening, a raw building from below as the water finds the cracks and begins to climb, and then it arrives. Not as a spring, not as a flood the way you have ever pictured a flood. It comes up through the shattered ground as an eruption of water, a churning violent surge bursting out of the broken crust under the full weight of all that buried pressure. The chaotic terrain you are standing in is filling, fast, with a torrent that has been waiting 3.5 billion years for this exact moment. This is where the scar begins, right here at the collapse, where the ground caved in and the buried sea came roaring back to the surface. Stay in that moment one breath longer and consider what it would actually be to witness it, because almost nothing in human experience compares. We are used to disasters that have edges, a flood that fills a valley, a quake that shakes a city, an eruption that buries a town. Those are local. They have a here and a there, a danger zone and a safe distance. What is happening at Xanthi Terra has no edge you could walk to. The ground is failing across a region larger than many countries. The water is erupting from a reservoir that underlies an entire territory, and there is no high ground nearby that is not also part of the same collapsing draining system. You're not standing at the edge of a disaster. You're standing in the middle of a planet rearranging itself, and the nearest place that is not part of the catastrophe is hundreds of kilometers away, across terrain that is itself coming apart. This is geology, operating at a scale that our instincts have no preparation for, a single event that reshapes a portion of a world in the time it takes a storm to pass. From this broken place, the water now has only one direction to go, and the land itself will decide its path, downhill, northward, toward the lowlands, and what it does on that journey is going to carve a wound 1,300 kilometers long. But first, you have to survive the wall of water that is right now rising toward you. Part 6. The most catastrophic flood. I want to stay in that moment, because the scale of what is being released is almost impossible to take in from a safe distance, and it deserves to be felt up close. So stand your ground one more time, downhill from the collapse now, on the open plain the water is racing toward. You hear it before you see it. a low, building roar, more felt than heard in the thin air, the ground beginning to tremble again in a steady rising rhythm. On the horizon, a line appears where there was no line before, a dark band stretching across your entire field of view. And then you understand what you're looking at. It is not a band. It is a front. It is the leading edge of a wall of water taller than any building you have ever stood beside, churning grey and brown, with the rock and ice it has already torn loose, and it is coming toward you at a speed nothing on legs could ever outrun. The air itself moves ahead of it, a hard wind shoved forward by the mass behind. And then it is on you, and there is nothing left to describe because you are inside it, and it is carrying everything away. And then, almost as fast as it came, the worst of it is past, and what is left behind is its own kind of strange. The leading wall moves on down the channel, chasing the lowest ground, but the water keeps coming behind it for hours, for days, a sustained torrent draining the broken reservoir dry. The land that was solid this morning is now a churning river, the width of a region. Blocks of ice the size of buildings ride the current, grinding against the channel walls. Mud and shattered rock roll along the bottom, scouring it deeper with every passing minute. The sound in that thin air is a low and ceaseless roar felt through the bones more than heard. And all of it is moving in one direction, downhill, northward, toward the lowlands, with the blind single-mindedness of water that has finally, after ages of confinement, been set loose. There is no malice in it, and no mercy in it. It is simply water obeying gravity at a scale that would erase a city without slowing down, pouring out of the planet's broken side toward the sea it is destined to help fill. That is the flood that carved the scar, and the numbers behind it break the mind a little. Scientists estimate that the amount of water released in events like this measured in the billions, possibly trillions of tons, surging out onto the surface not over years or even days, but in a window so short, geologically speaking, that it is closer to an instant. The discharge, the volume of water moving past a given point every second, would have dwarfed anything our own planet has ever produced. And Earth has produced some monsters. To really feel the difference, we have to bring in the largest floods our own world has on record, and then watch them shrink. Let me try to give the discharge a shape you can stand next to, because the raw figures are almost meaningless until you anchor them to something human. When hydrologists model the flow that carved channels like this one, they arrive at discharge rates, the volume of water passing a given point each second, that run into the millions of cubic meters per second, possibly far more. A single cubic meter of water is about the size of a kitchen appliance, and it weighs a ton. Now picture millions of those, every second, surging past you. For comparison, the mightiest river on Earth, the Amazon, which drains a continent and pours an unimaginable amount of fresh water into the Atlantic, moves something on the order of 200,000 cubic meters per second at its peak. The Martian flood may have moved water at rates dozens of times greater than the Amazon, not as a steady river that runs for thousands of years, but all at once, for hours and days, and then it was done. It is the difference between a faucet left running and a dam exploding. The Amazon is the faucet. This was the dam. On Earth, near the end of the last ice age, there were floods so enormous that geologists spent decades refusing to believe in them. In the Pacific Northwest of North America, a wall of ice holding back an entire inland lake gave way, and the lake, hundreds of cubic kilometers of water, drained out across the land in a matter of days. It scoured the ground down to bedrock, carved canyons, moved boulders the size of houses, and left a region so torn up that we still call it the Scablands. The geologist who first proposed that these features were carved by a single, catastrophic flood was ridiculed for years because the scientific world of his day simply could not accept that any flood could be that big, that violent, that fast. It took decades for the evidence to win. The idea that landscapes could be cut not by slow erosion but by sudden catastrophe was, for a long time, almost heretical. And that history matters here, because it is exactly the kind of catastrophic flooding that, once we accepted it on Earth, gave us the language to understand what we were seeing on Mars. The Scablands taught us to read the signs. Mars showed us the same signs, written far, far larger. And there is a lesson tucked inside that history that goes beyond geology. For a long time, we assumed the world was shaped only by slow, gentle, gradual forces, the patient wearing down of rock over unimaginable time, because that is what we mostly see in a human lifetime. Catastrophe, the sudden and the violent, felt like an exaggeration, almost like superstition. It took real courage for scientists to accept that landscapes could be carved in days by events of overwhelming force. But the universe, it turns out, is built from both. It has the slow and the patient, the rivers and the rain that take 1,000,000 years to cut a valley, and it has the sudden and the catastrophic, the floods and the impacts that can remake a region in an afternoon. Mars carries both kinds of writing on its surface, and the channel we are following is the catastrophic kind, the signature of a world that was usually slow and silent but, on one particular day, was anything but. Across the world, another megaflood helped tear open the channel that now separates Britain from mainland Europe, draining a frozen sea through a gap in the land in one of the largest floods our planet has ever known. These were, by any earthly measure, the most violent flood events in the history of our world. And here is the thing you need to hold on to. Set beside the flood that carved this Martian channel, our planet's greatest megafloods would have looked like puddles, like a spilled glass of water next to a breaking ocean. The Martian event was very likely the most catastrophic flood in the entire history of the solar system. It is worth pausing on why a planet that was already drying could produce a flood that outclassed anything on a planet covered in water. The answer is in the way the water was stored. Earth's floods come from water at the surface, in lakes and seas and ice, released over time. The Martian flood came from water that had been pressurized underground for millions of years and was released all at once, the entire pent-up reservoir emptying through a single broken wound. It was not rainfall, it was not a swollen river, it was a planet uncorking a buried sea under pressure, and the result was a discharge so violent it carved permanent geography in hours and days. The water did not have time to be gentle, it did not meander. It went straight for the lowest ground it could find, tearing rock apart as it went. It also rewrites how you should picture the very word flood, because what happened here was not really a flood in any sense a person from Earth would recognize. A flood on Earth is water arriving where it does not belong, the river over its banks, the sea over the shore, water from above or from beside. This was water from below. This was the planet's own buried reserves erupting upward through its broken skin under the pressure of ages. It was less like a river overflowing and more like a wound opening and bleeding out under pressure. The fluid driven not by rainfall or tide, but by the stored force of an entire confined reservoir finding its release. And once it reached the surface, it did not spread out lazily across a plain the way a flooding river does. It moved with the violence of all that pent-up pressure behind it, a torrent under power, scouring rather than soaking, cutting rather than covering. That is why it could carve permanent geography in a matter of hours. It was not water visiting the land. It was water escaping the planet and taking a 1,300-kilometer bite out of the surface on its way. And that is the strange, almost beautiful contradiction sitting at the center of this story. The most violent flood the solar system has ever seen happened on the planet we think of as the dead, dry one. The wettest event in the neighborhood took place on a world busy turning into a desert. It is as if Mars, in the act of losing its water forever, threw it all back onto the surface one final time in a single catastrophic release, and in doing so signed its name across its own face in a line 1,300 kilometers long. The flood was Mars's water making its last great appearance, and the channel it left behind has a name and a path and a destination that turns out to matter more than anything else in this story. Because the water was not just escaping, it was going somewhere. And where it was going is going to change how you see this entire planet. Part 7. Shalbatana Vallis. The channel has a name, and even the name sounds like it was carried up out of the far past. Shalbatana Vallis. Geologists call a feature like this an outflow channel, and that term is doing a lot of quiet work, so it is worth unpacking. When you hear the word channel, you probably picture a river, something carved patiently over millions of years by water flowing year after year, season after season, wearing the rock down a little at a time. An outflow channel is the opposite of that idea. It is not the work of patience. It is the work of a single, sudden, overwhelming release, a valley cut not by a steady river, but by a violent flood that came and went in a geological blink. Shalbatana Vallis is the frozen record of that one event, and it begins, exactly as you would now expect, at the collapse zone, right where the ground caved in and the buried water came roaring out. From the broken ground, the floodwaters did not hesitate, and they did not wander. They surged downhill, following the only thing that matters to water, which is gravity, the pull toward the lowest available ground. And as they went, they carved. Picture the sheer power of it. Water moving with that much force, carrying that much rock and ice as cargo, does not flow over a surface so much as attack it. It grinds, it plucks, it tears loose blocks of bedrock that had stood untouched for billions of years and hurls them downstream. With every passing hour, the channel cut deeper and wider, the flood widening its own road as it raced along it. Rock that had been solid since the planet's youth was opened up and swept aside in an afternoon. The water was writing a line across the planet, and the pen was pressing hard. Shalbatana Vallis winds its way for roughly 1,300 kilometres, turning and broadening as it descends, before it finally empties out of the highlands and onto a wide, flat, low plain to the north. And now you can come back to that very first image, the one we started with, and see it for what it truly is. The scar the length of Italy is not a wound the planet suffered passively. It is the signature of the flood. It is the exact path the water took on its one violent journey from the broken ground at Xanthi Terra down to the lowlands. Every turn in that channel is a place the water turned. Every widening is a place the flood spread out and pressed harder. When the European spacecraft photographed it days ago, it was photographing a record that has not moved an inch in 3.5 billion years, a line of cause and effect preserved more perfectly than almost anything on Earth, where rain and wind and life would have softened and erased it long ago. On Mars, with no rain to wash it, and no rivers to recut it, the scar simply stayed, waiting to be read. If you look closely at the floor of an outflow channel like this one, you find features that are almost like reading the water's own notes about what it did. Scattered along the channel are what scientists call streamlined islands, teardrop-shaped mounds of rock that the flood flowed around rather than over. They form where some harder lump of bedrock, often the rim of an old crater, stood firm against the torrent, and the water split and rushed past on either side, sculpting the rock behind it into a long smooth tail, pointing downstream, exactly the way sand builds up behind a stone in a fast river. These teardrop islands are like arrows frozen into the planet, every one of them pointing in the direction the water flowed, every one of them a record of the current's path. You can stand in orbit, look down, and read the direction of a flood that ended 3.5 billion years ago, just from the shape of the islands it left behind. The water is gone, but it left its handwriting everywhere. There is something else the channel reveals that is easy to miss but profound. These outflow channels did not all form in a single event necessarily. Some of them show signs of being carved by more than one flood, the ground breaking open and flooding, then sealing and pressurizing again, then breaking open once more, episode after episode across long stretches of time. It is as if the planet had a recurring wound that reopened, a pressure that kept building and releasing, each cycle pouring more water down the same path toward the lowlands. That changes the picture from a single freak accident into something more like a pattern, a planet repeatedly venting its buried water through the same scars, draining itself northward again and again as it slowly died. The channel is not just the record of one bad day. It may be the record of a long episodic bleeding out, a world emptying its hidden reserves a flood at a time. And there is something the channel can tell us, just by its shape, that goes beyond the drama of the flood. The way these outflow channels are carved, the patterns left in their floors, the streamlined islands of rock the water flowed around and left standing, all of it lets scientists estimate just how much water moved through and how fast. This is how we know the discharge was so staggering. The evidence is written into the geometry of the channel itself. The water signed its work and also, without meaning to, left behind the measurements. We can stand at this channel, 3.5 billion years later, and reconstruct the fury of a flood no living thing ever witnessed, because the rock remembers what the water did to it. That phrase is worth pausing on, because it is the quiet miracle that makes all of this possible. No camera recorded the flood, no instrument measured it, no eye, human or otherwise, ever saw a drop of it fall. Everything we know about the most violent flood the solar system may have ever produced we know because the rock kept the record. The shape of the channel, the height of its walls, the streamlined islands, the chaos at its head, all of it is testimony, written not in words but in stone, by the event itself. The planet is its own witness. Mars wrote down what happened to it in the only language a planet has, which is the shape of its own surface, and then it preserved that writing for 3.5 billion years until a species on the next world over learned enough to read it. That is what we are doing when we look at that image. We're reading a planet's account of the worst day it ever had in its own hand. I find it worth sitting with the permanence of all this, because it is one of the things that makes Mars so unlike home. On Earth, a flood of this kind would have been erased almost as fast as it formed, in geological terms. Rain would have softened the channel walls, rivers would have recut the floor, plants would have crept in and held the soil, wind and weather and the slow grinding of a living, restless planet would have worn the whole feature down until, in a few tens of millions of years, you might never know it had been there at all. Earth does not keep its scars. It heals them, buries them, recycles them. But Mars, after the water left, had none of those healing forces. No rain to soften the walls, no rivers to recut the floor, no plants, no weather worth the name, no churning crust to swallow the evidence. So the channel simply stayed, exactly as the flood left it, for 3.5 billion years. When you look at that image from orbit, you're not looking at a worn-down memory of a flood. You're looking at the flood's own work, nearly fresh, as if it happened in a season that never ended. Mars is a planet that does not forget, and that is precisely why it can teach us things Earth has long since erased about itself. But a channel is only half a story. A channel is a path, and a path has to lead somewhere. All that water, those billions or trillions of tons of it, did not simply race down Shalbatana Vallis and vanish at the end. It went somewhere specific. It poured out of the highlands and spread across the flat ground to the north, and that flat ground has a name too, and a secret. Because Shalbatana Vallis was not the only channel doing this. It was one of many, a whole network of these enormous outflow channels, all of them draining out of the equatorial highlands and pouring their floods toward the same low region in the north. They were all feeding something, and when you trace where they were all heading, when you stand at the mouth of Shalbatana Vallis and look out across the plain it empties into, you are looking at the floor of what may have been an ocean. Part 8. The Golden Plain. The plain at the end of the channel is called Kreisplanitia, and the name, translated roughly, means the Golden Plain. From orbit it earns the name. It is a smooth, relatively flat expanse spreading across part of the northern half of Mars, and in the low Martian sunlight it can take on a soft golden colour, an enormous calm basin sitting at the foot of the broken highlands. It is one of those places that looks, at first glance, like nothing much at all, just a flat plain. But the flatness is the clue. The flatness is the thing that should make you stop. Because flat, smooth, low-lying ground, ringed by the mouths of ancient flood channels, is exactly what the floor of a former sea would look like. There is a broad fact about Mars that makes this whole idea click into place, and once you see it, you cannot unsee it. The two halves of Mars are profoundly different. The southern half of the planet is high, old, and heavily cratered, ancient highland terrain standing at elevation. The northern half is low, smooth, and comparatively young-looking, a sweeping basin that sits kilometres below the southern highlands. Scientists call this the Great Dichotomy, the planet's split personality, and it has been recognised for a long time. Now think about what low, smooth, flat ground in the northern half of a planet would do if that planet had water. Water runs downhill, water pools in the lowest ground. If Mars had oceans, there is exactly one place they would have gathered, and it is the enormous low northern basin, the very region that all those equatorial outflow channels, Shalbatana Vallis included, were draining into. The geography of the whole planet is shaped like a bowl with the rim in the south and the basin in the north, and the floods all ran toward the bottom of the bowl. The ocean hypothesis is not some exotic add-on. It is what the shape of the planet predicts. When scientists study the geology of Creasy and the broader northern lowlands, when they trace the faint lines that run along the terrain at consistent heights, they find something that is hard to explain any other way. They find what look like ancient shorelines, not one, but possibly several, marking different water levels at different times, the way the rings around a drying lake on Earth mark where the water once stood. It is honest to say that this is debated, and the debate itself is part of why the story is so interesting. The proposed shorelines are old and worn, and over billions of years the surface of Mars has shifted and tilted in places, so the lines are not as crisp and level as a fresh beach would be, and some scientists have argued they are not shorelines at all. But the case has only grown stronger as the evidence has accumulated because it is not resting on the shorelines alone. It rests on the shorelines, and the deltas, and the outflow channels all draining the same direction, and the low flat basin shaped exactly like an ocean bed, and the sediments, and the minerals, all pointing the same way at once. Any single piece could be argued. The convergence of all of them is what makes the Northern Ocean one of the most compelling ideas in planetary science, even if its exact size and depth and lifetime are still being worked out. The argument is not whether Mars had standing water in the north. The argument is how much, and for how long. And that is a very different kind of question from the old assumption that Mars was always dry. They find that these proposed shorelines tend to sit at roughly the same elevation over enormous distances, which is exactly what you would expect from the edge of a single connected body of water, because water always finds its level. And in one remarkable case, right inside Shalbatana Vallis itself, researchers identified the fan-shaped deposit of an ancient delta, sitting at a height that lines up with one of those proposed water levels, dated to around 3.5 billion years ago. A delta forms where flowing water meets standing water. To find one here is to find the fingerprint of a shore. Put it all together, and a picture rises out of the data that is genuinely hard to hold in your head the first time. The northern lowlands of Mars, including this golden plain, may once have been the floor of an ocean. Not a pond, not a regional sea, but an ocean large enough to cover a significant fraction of an entire hemisphere of the planet. And every one of those outflow channels, Shalbatana Vallis included, every catastrophic flood that tore down out of the highlands, was ultimately draining in the same direction, pouring its water northward into this growing sea. The floods were not just random catastrophes, they were deliveries. They were the planet moving its buried water back up to the surface and out into a northern ocean, one violent release at a time. Let me put you on that shore because a map of an ancient ocean is one thing, and standing on its edge is another. Imagine you are there, 3.5 billion years ago, at the margin of the Northern Sea. The sky above you is not the black of space and not the blue you know from home, but something stranger and softer, perhaps a pale, hazy colour tinted by a thin and dusty atmosphere. The sun hangs smaller and weaker than the one that warms your face on Earth, because the young sun was dimmer then, and so the light has a cool, gentle quality, like a long afternoon that never quite commits to evening. In front of you, water stretches to the horizon. Real water, liquid and moving, cold and grey, with slow waves rolling in and breaking against a shore of dark volcanic sand. The air is thin, but it is there, and it carries the faint, unmistakable smell of water, the smell of a coastline. Behind you, the highlands rise, scarred with the channels that fed this sea. You're standing on the beach of another world, and it is not dead. It is alive with weather and water and motion. Bend down, if you can, and look at the water at your feet. It is cold, and it is real, and if you cupped it in your hands it would behave exactly as water behaves at home, running between your fingers, catching the weak light. There might be a thin crust of ice along the colder edges of the shore where the shallow water meets the freezing air, and farther out the surface might steam faintly where it is warmer than the atmosphere above it. This is a working coastline on another planet. Waves are shaping the sand, sediment is settling on the seafloor in patient layers, the same layers that, billions of years from now, scientists will search for the trace of anything that might have lived here. Every ordinary feature of this shore, the waves, the ice, the steam, the settling mud, is a process that an earthly coast would have too, running quietly on a world that is not Earth. For this moment, in this place, Mars and home are nearly the same kind of world, two living coasts under two pale skies, and it has no idea, and you cannot tell it, that all of this is temporary. It is worth knowing that we have actually been to this plane. When humanity sent its first successful lander to touch the surface of Mars, back in the 1970s, one of the two craft set down right at the edge of this very region, on the Golden Plain itself. It sent back the first clear photographs ever taken from the Martian surface, a rock-strewn rusty desert under a pale sky, and for the people who saw those images, that became the face of Mars, the definitive picture of a dead and dusty world. And here is the quiet irony that took us decades to appreciate. That lander was sitting on what may have been the floor of an ancient ocean. The desert it photographed, the dry rocks, the rust, the emptiness, all of it was resting on the bed of a vanished sea. We landed on a beach and saw only the desert it had become, because we did not yet know how to read what we were standing on. The ocean had been gone so long that its own floor looked like it had never been anything but dust. That is the image I want you to carry forward, because everything after this is about losing it. A real ocean, on Mars, under a pink sky. It is not a fantasy, and it is not a painting. It is, as best we can reconstruct, a place that genuinely existed, that you could have stood beside and waded into, on the planet that we now think of as the very definition of dead and dry. And the fact that it was there at all forces the question that the rest of this story is built around. A world with an ocean, and rivers feeding it, and floods and shorelines, is not just a world with water. It is a world with a system, a world that breathes. And to understand what Mars lost, we have to understand that the planet was not merely wet. For a while, it was working. Part 9. A living, breathing water world. I want to slow down here, because we have reached the part of the story that changes how the whole thing feels, and it deserves room to land. Up to now, we have been talking about water as a substance, something that pooled and froze and flooded. But an ocean fed by rivers, with shorelines and deltas and floods that recur, is not just a puddle that happens to be large. It is the visible part of a cycle. On a world like that, water does not sit still. It evaporates from the sea into the air. It gathers into clouds. It falls again as rain or snow over the highlands. It runs down through valleys and rivers back toward the lowlands, carving the land as it goes, and it collects once more in the sea, and then it begins again. That loop, sea to sky to land to sea, has a name on our planet. We call it the water cycle, and the evidence is telling us that Mars billions of years ago had one too. Stop and feel the weight of that, because it is easy to read past it as just another fact. A water cycle is not a minor feature of a planet. It is, in a real sense, the circulation of a living world. It is the same process that makes Earth green, that fills our rivers, that waters every forest and every field, that has shaped nearly every place a human being has ever called home. There is a reason we are so fixated on water when we search the sky for life, and it is worth understanding because it makes what Mars had so much more significant. Water is not just a drink. For the kind of chemistry that life depends on, water is the stage on which everything happens. It dissolves things, carries them, brings them together, lets molecules find each other and react and build into something more complicated. Liquid water is the meeting place, the medium, the room where the chemistry of life can actually take place. Without a liquid like it, the necessary molecules just sit there, frozen apart or scattered, unable to mix. So when we find a world that had liquid water, and not for a moment but for a long, stable stretch of time, we are not just finding a world that could have been pleasant. We are finding a world that had the one thing life seems to need above all others, the room where it could begin. Mars had that room. It had it furnished, and warm, and full, for a very long time. When we look for life on other worlds, the very first thing we look for is liquid water, and we look for it precisely because a world with flowing, cycling water is a world with the basic machinery that life, as far as we know, requires. Mars had that machinery. Mars had rain, and rivers, and an ocean, and clouds, and evaporation, and the long, slow circulation of water from sea to sky and back. For a stretch of time longer than the entire history of complex life on Earth, Mars was not a rock. It was a working world. There is a tendency, when we talk about water on other worlds, to treat it as a chemistry problem, a box to check, water present, yes or no. But a water cycle is not a box. It is a kind of breathing. Think about what it actually involves. The sun warms the sea, and water lifts invisibly into the air as vapor. The vapor rises, cools, and gathers into clouds. The clouds drift over the land and release their water as rain or snow. That water lands on high ground and begins to flow downhill, gathering into streams and rivers, cutting valleys, carrying sediment, until it reaches the sea again, and the sea rises to meet it, and the warmth lifts it once more, and the whole thing turns over again and again, without pause, for as long as the world stays warm enough to keep it going. It is a circulation, a loop, a system that connects the sky to the sea to the stone and back. And it does not just sit there being beautiful. It shapes the planet. It carves the canyons, builds the deltas, lays down the sediments, moves the chemistry around, mixes the ingredients. A water cycle is a planet stirring itself, keeping itself in motion, and on Earth it is inseparable from the fact that our world is alive. And here is the realization that I think sits at the very center of this entire story, the one that should make you set down whatever you're doing and just sit with it for a moment. When we say a planet is alive, we do not usually mean that it has creatures on it. We mean that its systems are running. We mean that air is moving and water is cycling and the whole interconnected machine of a world is turning over, the way Earth's is turning over right now, the way it has turned over for billions of years, the reason you can step outside and feel wind and see clouds and watch rain fall. That is what it means for a world to be alive, and by that measure, Mars was alive. It had everything Earth has, the same circulation, the same cycle, the same breathing in and breathing out of water between the ground and the sky. Two worlds side by side, both of them alive in exactly that sense. And then one of them stopped. I want to let that land without rushing past it, because it is the hinge of the entire story. For a stretch of time longer than the whole history of animals on Earth, there were two living worlds circling our sun side by side, both breathing water between sea and sky. Two, not one. If you could have stood outside the solar system in that ancient era and looked in, you would have seen a pair of blue and white worlds where today there is only two places where the machinery of a planet was turning over, two coastlines, two sets of weather, two chances. And then slowly one of those worlds went quiet. Its seas drew down, its sky thinned, its weather faded. The circulation that had defined it as a living world wound down and stopped, and the pair became a single, and the single is us. And we did not even know there had ever been two until we learned to read the marks on the other one. We are not just looking at a dead planet when we look at Mars. We are looking at the place where we lost our only neighbour. I think the reason this lands so hard is that it quietly undoes a story most of us carry without realising it. We tend to assume, somewhere far down, that Earth is the way it is because it was meant to be, that life and oceans and blue skies are the natural and inevitable result of a planet sitting in the right place. Mars breaks that assumption in half. Here is a world that sat in nearly the right place, that had the water and the warmth and the air and the time, that started down exactly the same road we did, and it did not arrive. Not because it was cursed, not because it was missing some magic ingredient, but because of a difference in size that determined how fast its core cooled. The gap between a living world and a dead one turns out to be terrifyingly small, and largely a matter of luck and timing. Earth is not the rule that Mars failed to follow. Earth and Mars are two rolls of the same dice, and we happen to be standing on the one that came up alive. That is not a comfortable thought. But it is, I think, a true one, and the golden plane is where it stops being an abstraction and starts being a place you could have stood. That is the part that turns wonder into something closer to grief. Because the difference between Mars and Earth is not that Earth was always destined for life and Mars never had a chance. The difference is that both worlds started the same race, both of them alive and breathing and cycling water under their early skies, and one of them kept going and one of them did not. Mars did not fail because it was a bad planet. It did not lack water, or warmth, or time. It had all of it, and it lost all of it anyway. The ocean we stood beside, the rivers, the rain, the clouds, the whole living system, every part of it eventually went still and cold and silent. The machine that was turning over for hundreds of millions of years simply stopped turning. And when a planet's systems stop, they do not start again on their own. And notice what kind of loss this is, because it is not the dramatic kind we are used to fearing. We tend to imagine the end of a world as a catastrophe, a giant impact, an exploding star, some single terrible event that arrives and destroys. But this was nothing like that. There was no day the ocean died. There was no moment you could point to and say, "There, that is when Mars ended." The death was made entirely of ordinary days, each one almost identical to the last. The sea a fraction lower, the air a fraction thinner, the cold a fraction deeper, none of it perceptible within a single lifetime, all of it adding up across millions of years into total and permanent loss. That is a harder kind of ending to grasp, because it has no villain and no climax. It is just a slow accumulation of small subtractions, a world being taken apart so gradually that on any given day nothing seemed to be wrong, and in a way that is the most unsettling version of how a world can die, not in fire, but in a long quiet series of unremarkable afternoons, each one taking a little more, until one day there is nothing left to take. So the question that has been hovering over this entire story finally has to be faced directly, because it is the question that haunts every scientist who looks at that golden plain and those ancient shorelines. What could possibly do this? What could take a world with an ocean and a water cycle and a thick enough sky to hold the warmth and strip all of it away and leave behind the frozen, battered desert we see today? It was not a single catastrophe. It was not the flood, which was a symptom and not the cause. It was something slower and stranger, and in its own quiet way far more frightening than any flood. It was a failure far down in the machinery of the planet itself, and it started of all places in the core. Part 10. How a Planet Dies. To understand how Mars died, you have to go down past the surface, past the buried reservoirs, all the way to the centre of the planet, to the core. Every rocky world has one, a centre of metal, mostly iron, and in a young, hot planet that iron core is not solid and still. It is molten, churning, a sea of liquid metal in constant motion, stirred by the heat trying to escape from the planet's interior. That churning is not just a curiosity. It is one of the most important things a planet can do, because moving liquid metal generates a magnetic field. The same way a spinning dynamo produces electricity, a churning metal core produces a magnetic field that wraps around the entire world. Earth has one right now. It is the reason a compass needle points north. And 4 billion years ago, Mars had one too. It is genuinely strange, when you think about it, that the fate of an ocean could depend on something as hidden and as abstract as the motion of metal at the centre of a planet. We never see a core. We never feel a magnetic field, not really, beyond the gentle swing of a compass needle. These are the most buried, most invisible parts of a world, and yet they turn out to be the things that decide whether that world gets to keep its sky and its seas. There is a chain of dependency here that is worth laying out plainly, because it is the skeleton of the whole tragedy. The water depends on the air depends on the magnetic field depends on the churning core, and the churning core depends on the planet staying hot inside. Pull out the bottom link, let the core cool, and the whole chain unravels upward, link by link, until the water at the very top has nowhere to stay. Everything you could see and touch on the surface of a living world, every ocean and cloud and rainfall ultimately hangs from a hot spinning core you can never lay eyes on. It is a humbling architecture, and Mars is what it looks like when the bottom link finally lets go. That magnetic field is far more than a navigation aid. It is a shield. Out from the sun, in every direction, blows a constant stream of charged particles called the solar wind, racing across space at hundreds of kilometers per second, on the order of 400 kilometers every single second. That wind is relentless, and it is erosive, and left unchecked, it will strip the air right off a planet particle by particle. A global magnetic field stops that from happening. It deflects the solar wind, channels it harmlessly around the world, holds an invisible umbrella over the atmosphere so that the air and the water it allows to exist can stay. As long as the core churns, the field holds. As long as the field holds, the air is safe. Everything, the ocean, the rivers, the rain, all of it depended on that buried invisible engine continuing to turn. We are not guessing about this magnetic past, by the way. We can read it directly in the rock. When molten rock cools and solidifies in the presence of a magnetic field, it locks in a faint record of that field, freezing the orientation of the magnetism into the stone like a snapshot. When spacecraft mapped the magnetism of the Martian crust, they found whole regions of ancient rock that are strongly magnetized, carrying the frozen fingerprint of a global field that existed when that rock first cooled. And then, in the younger rock, in the great impact basins that formed later in the planet's history, that magnetism is largely absent. The record stops. The field that magnetized the old rock was simply not there anymore by the time the younger rock formed. So we can actually date, roughly, the death of the Martian dynamo by finding the line in the rock where the magnetism switches off. The planet kept the receipt of its own dying core, and we found it written in stone. But Mars had a problem, and the problem was size. Mars is a small world, only about half the diameter of Earth, and small worlds have a fatal disadvantage. They cool faster. A small planet has less heat stored inside it, and more surface area, relatively speaking, through which to lose that heat to space. And as the interior of Mars cooled, the churning of its core began to slow. Around 4 billion years ago, the engine started to fail. The liquid metal moved less and less vigorously. And as the churning died down, the magnetic field it generated weakened, and then, somewhere around that ancient time, it collapsed almost entirely. The umbrella folded up, the shield came down, and for the first time in its history, Mars stood naked before the Sun. There is a cruel piece of timing buried in this sequence that is worth drawing out, because it explains why the death was so thorough. The magnetic field did not fail at some convenient later date, after the water was safely gone. It failed early, near the very beginning of the planet's wet, promising youth, which means that for almost the entire time Mars had its ocean, and its rivers and its rain, the shield was already down, and the atmosphere was already leaking, and the clock was already running. The wet, living Mars we have been describing was not a stable, settled world that lasted for ages and then suddenly died. It was a world living on borrowed time from very near the start, holding on to its water and its air for as long as it could, while the solar wind picked the sky apart overhead. The oceans existed in the same era that the atmosphere was already bleeding away. The whole warm, wet chapter of Martian history may have been, in a sense, a long goodbye that began almost as soon as the story did. The planet was beautiful and dying at the same time, and the dying had a head start. Let me take you above the planet to see what happened next, because it is one of the quietest catastrophes in the solar system, and almost no one ever pictures it. Float with me high above ancient Mars and compress the time, so that hundreds of millions of years pass in a few breaths. Below you the world still looks alive, the northern ocean catching the dim light, clouds drifting over the highlands. But the protective field that once wrapped the planet is flickering, weakening, going out like a dying ember. And now, watch the edge of the atmosphere. The solar wind, no longer turned aside, is slamming into the upper air directly, and where it strikes, the air begins to come apart. Molecule by molecule, the atmosphere is being peeled away into space, a thin, endless bleed of gas streaming off the planet's dayside and trailing away into the dark behind it. There is no explosion. There is no sound. There is only the slow, patient theft, year after year after year, the sky of an entire world being carried off into space one particle at a time. We have actually watched this happen in our own era. A spacecraft now orbiting Mars has measured the atmosphere still escaping today, still bleeding away, the last thin remnants of that ancient theft continuing in real time. Here is a detail that makes the whole process feel even more real, and even more relentless. We are not reconstructing this purely from theory. We have a spacecraft in orbit around Mars right now, whose entire job is to study how the planet loses its atmosphere, and it has caught the process in the act. It measures the solar wind slamming into the upper atmosphere, and it measures the atmosphere streaming away in response, and it has watched that lost spike when bursts of activity erupt from the Sun and slam into Mars. We can see, in real time, the last thin remnant of the Martian sky being carried off into space, the same theft that began 4 billion years ago still grinding along today, just with almost nothing left to steal. Imagine that. The crime is still in progress. The atmosphere that the floods erupted into, the sky that once held an ocean's worth of weather, is down to a fraction of a percent of Earth's, and even that is still leaking away, particle by particle, into the dark. We did not just deduce the death of Mars. We arrived in time to watch its final faint exhalation, and as the air thinned, the water was doomed, though not in the way you might expect. The oceans did not simply freeze into a solid sheet and sit there. As the atmospheric pressure dropped lower and lower, it crossed a threshold below which liquid water cannot exist on the surface at all. Below that pressure, water does not flow and it does not freeze. It evaporates. It turns straight to vapour and rises, and once it is vapour in a sky with no shield, it too is exposed to the solar wind and stripped away. So the ocean we stood beside did not die in a single frozen moment. It died the slowest death imaginable, evaporating molecule by molecule, the sea level dropping across millions of years, the water leaving the surface and then leaving the planet entirely, lost to the same void that was stealing the air. The shorelines we can still trace are the high water marks of that long retreat, the rings left behind as a world's oceans slowly disappeared into space. And there is a specific cruelty to dying this way, by evaporation rather than freezing. If the ocean had simply frozen, it would still be here, a sheet of ice waiting for some future warmth to bring it back. Frozen water is water kept. But Mars did not get to keep it. As the pressure fell, The water did not lock itself away as ice on the surface where it might be recovered. It turned to vapour and rose into a sky that could no longer hold it, and from there it was stripped away into space by the same solar wind that had taken the air. So the loss was not a pause. It was not a long winter that might someday end. It was a permanent subtraction, the water leaving the surface and then leaving the planet entirely, gone not into storage but into the void. The ocean did not fall asleep. It was carried off, molecule by molecule, and it is not coming back. And this is where the comparison to Earth stops being an interesting parallel and becomes something that should give you pause. The only reason our own sky is still here, the only reason you can step outside and breathe and feel the wind and watch the rain, is that our planet's core is still churning. Earth is larger than Mars, so it has held its interior heat longer, and that heat keeps our liquid metal core in motion, and that motion keeps our magnetic field strong, and that field keeps the solar wind from stripping our air the way it stripped Mars. Everything you love about being alive on this planet, the blue sky, the oceans, the green, traces back to a hot spinning core you will never see, far beneath your feet, doing the one thing Mars's core stopped doing. We are not safe because we are special. We are safe because our core is still warm, and cores given enough time cool. Ours will too, billions of years from now. Mars is not just a dead world next door. It is a preview, a slow and silent foreshadowing of the fate that waits for any world whose engine eventually runs down. This is the part that I find genuinely difficult to sit with, and I think it is the real weight at the centre of this whole story. Mars did nothing wrong. There was no disaster, no impact, no villain, no mistake. The planet simply did the one thing every planet does, which is cool down over time, and because it was small, it cooled a little too fast, and its core stopped churning, and its field came down, and everything else followed from that one quiet, unavoidable fact of physics. A world cannot choose to keep its core hot. A world cannot decide to hold on to its magnetic field. Mars had an ocean, and a sky, and a living water cycle, and it lost all of them not through any catastrophe it could have seen coming or fought against, but through the slow, indifferent cooling of its own interior. It tells you something humbling and a little frightening about what it means for a world to be habitable. It is not a permanent property. It is not something a planet earns and gets to keep. It is a temporary fragile balance, held up by a hot core and an invisible field, and it can be lost, completely and forever, with no one to blame. Mars is the proof, lying right there beside us, a world that had everything and could not keep it. And yet, for all of that loss, the story does not quite end in emptiness. Because remember where so much of the water went, before the air ever failed. Remember the dark. Part 11. What's still down there? Here is the part of the story that turns, just slightly, back toward hope. We have spent a lot of time on what Mars lost, the ocean stripped away, the air bled into space, the long death of a world. But not all of the water followed the air into the void. A great deal of it never made it to the surface to be stripped away at all, because it had already retreated underground long before, into the cold and the rock. And underground, sealed away from the thinning sky and the stealing solar wind, it was protected. It could not evaporate into a sky that was vanishing if it was buried hundreds of meters below the ground. And so it stayed, frozen, hidden, locked into the crust of the planet. The water had nowhere left to go, and so it simply stayed where it was, and it is still there. Let me say that again, because it is the answer to the question this whole journey has been circling. Mars is hiding something enormous beneath its surface, and that something is water. Not a trickle, not a memory of water, but enormous quantities of it, preserved as ice in the ground across much of the planet. We have mapped buried sheets of ice, glaciers covered over by dust and rock, ice locked into the soil, layered ice stacked at the poles thick enough to bury cities. Spacecraft carrying radar instruments, designed to see down through the surface the way a doctor's scan sees through skin, have traced these hidden deposits, peering into the crust and finding water where the surface shows only dust. One of those radar instruments, aboard the same kind of orbiter that took our opening image, even detected signs of what may be liquid water, briny and cold, pooled beneath the ice at the southern pole, though that particular finding is still argued over. The point stands regardless. The water that fled underground 3.5 billion years ago, the buried sea whose rupture carved our scar, did not all escape. Much of it is exactly where it went, still down there, still waiting. The scale of what is still buried is genuinely hard to take in. In the middle latitudes of Mars, far from the poles, spacecraft have found entire glaciers, sheets, and lobes of water ice, hidden beneath a protective blanket of rock and dust just thick enough to keep them from sublimating away. From the surface, these places look like ordinary rolling ground. From orbit, with radar that can see through the dust, they reveal themselves as buried slabs of nearly pure ice, in some cases hundreds of meters thick, lying in wait under a thin coat of debris. There is so much of it that if you could somehow gather all the water ice known to be locked in and under the Martian surface and melt it and spread it evenly across the whole planet, it would cover Mars in a layer of water meters thick, a global sea reconstituted out of the hidden ice. The ocean did not entirely vanish. A great deal of it just changed its state and its address. It froze, and it hid, and it stayed. Picture standing in one of those middle latitude regions today. The ground around you looks like nothing special, just rolling rust-coloured terrain under a pale sky. But a few meters beneath your boots, sometimes less, there is a slab of ancient ice, water that has been frozen and waiting since the world was young. You're standing on the lid of a buried glacier, and you would never know it from the surface. The whole planet is like this, holding its water just out of sight, the desert above and the ice below, a world wearing a mask of death over a body that is still, in the most literal sense, full of water. We spent a century thinking of Mars as the dry planet. It turns out Mars is one of the wettest places we know of outside of Earth. It just keeps its water where the surface cannot reach it. There is a quiet symmetry in that, and I want to make sure you feel it. The same instinct that drove the water underground in the first place, the retreat from a hostile surface into the protection of the dark, is the reason any of it survived at all. The water hid, and the hiding saved it. The surface of Mars became a place where water could not exist, but the water had already gone somewhere the surface could not reach. When that buried reservoir at Xanthi Terra broke open and flooded out, that was water losing its hiding place, coming back up into a world that could no longer hold it, and being lost. But the water that stayed buried, the water that never found a crack, the water that kept its lid, that water endured. It is still keeping its secret. The phrase we used near the beginning was that the water had nowhere left to go. And that was true, and it sounded like the saddest thing in the world, the image of water trapped in a planet dying. But turn it over, and it means something else entirely. The water had nowhere left to go, so it is still here. It did not leave. It is waiting in the dark, in the cold, in the same ground it retreated into when the sky began to fail. It is worth saying plainly why the location of this water matters so much beyond the poetry of it. Water is heavy, and launching it from Earth is staggeringly expensive, which means that any serious future for humans on Mars depends almost entirely on water that is already there. A buried glacier is not just a scientific curiosity to a future explorer, it is survival. Melt it, and you have drinking water. Split it into its two elements, and you have oxygen to breathe and hydrogen to burn. Combine those elements in the right way, and you have the propellant to launch a rocket back off the surface and home again. Every one of those needs, the air, the water, the fuel, comes out of the same buried ice. So the hidden water beneath that scarred surface is not only the relic of an ancient ocean, it is potentially the thing that makes the difference between Mars being a place we visit for a few weeks and Mars being a place where people could actually stay. The planet's deepest secret may turn out to be the foundation of its second chance, and that changes what Mars is, in a way that matters enormously for what comes next. A planet that lost all its water is a closed book, a corpse, a finished story. But a planet that still holds enormous reserves of water, locked away and preserved, is something else. It is a planet that kept its most important secret. For any future where human beings actually go to Mars, that buried water is not a curiosity. It is everything. It is drinking water. It is the oxygen you breathe split out of the molecule. It is the hydrogen and oxygen that make rocket fuel for the journey home. The entire question of whether people could ever live on Mars rather than just visit it rests on the water that is hidden beneath that scarred surface. The enormous thing Mars has been hiding is not just a clue to its past, it may be the foundation of its future. But there is one more secret buried with that water, and it is the one that keeps the scientists who study this planet awake at night. Because if Mars had liquid water for hundreds of millions of years, and a living water cycle and an ocean, and all the right ingredients, then it had everything that a certain very particular and very precious process needs to begin. And the water that fled underground, the water that hid and was preserved, may not have fled alone. To face that possibility, we have to stand one last time at the mouth of our channel and ask the oldest question there is. Part 12. Did anything live in it? Come back with me, one final time, to Shalbatana Vallis, but now to the channel as it is today, in our own era, under the thin pink sky of the modern dried-out Mars. Stand on the dusty floor of the outflow channel, where 3.5 billion years ago a wall of water taller than a building roared past at the speed of a freight train. It is silent now. The cold is brutal, far below freezing, and the air is so thin it would not sustain you for a moment. Rust-coloured dust stretches in every direction, drifting in faint patterns where the weak wind has pushed it. Above you, the walls of the channel rise, carved by a flood no living thing ever saw. Listen to the silence of it, because it is a particular kind of silence. It is not the silence of a place that was always empty. It is the silence of a place that used to be loud. Where you're standing, water once moved at a scale that would have filled the air with a roar you could feel in your chest if there had been enough air to carry it. Now there is almost no air, and no water on the surface, and no sound at all but the faint hiss of dust moving in a thin wind. The channel around you is the shape of a scream frozen in stone, the record of the most violent flood the solar system may have ever produced, and it is utterly, completely quiet. That contrast between the fury that made this place and the stillness that holds it now is the whole emotional weight of Mars in a single moment. It is a world that was once loud with water and is now silent with cold, and the silence is not peace, it is aftermath. And beneath your boots, somewhere down in the cold rock, there is still water, frozen and ancient, a grain of the same sea that carved this place. You're standing inside a wound on a world, and the wound has been waiting all this time to be read. Mars is trying to tell us something. We're finally, just now, learning how to listen. And the thing it may be trying to tell us is the heaviest possibility in all of science. Because on Earth, we have learned something humbling about how life begins. As far as we can tell, it does not take long. Within a few 100 million years of liquid water appearing on our young planet, life was here. Simple, microscopic, single-celled life, but life. It seems that wherever you have liquid water and energy and the right chemistry and enough time, life has a way of getting started, almost as if it is waiting for the conditions and then it simply begins. And Mars, billions of years ago, had liquid water. It had energy from its warm interior and its chemistry. It had the right ingredients. And it had that water not for a season but for hundreds of millions of years, the same window in which life took hold on Earth. So the question is not really whether Mars had what life needs. We know that it did. The question is whether, in all that water and all that time, anything actually crossed the line from chemistry into biology. Think about what that comparison really implies, because it is easy to say and hard to feel. On Earth, life did not wait around. It did not require billions of years of perfect conditions and a long run of luck. As soon as our planet had stable liquid water, life appeared. Fast, in geological terms almost immediately. That suggests, though it does not prove, that the jump from non-living chemistry to living biology might not be some fantastically rare miracle, but something that happens readily wherever the conditions are right. And if that is true, then Mars becomes the single most important test we have ever had access to. Because here is a second world, right next door, that had the right conditions, liquid water, energy, chemistry, and time, for a window comparable to the one in which life took hold here. If life starts easily wherever it can, then it should have started on Mars. The ancient Martian ocean should have come alive the same way ours did. So the floor of that vanished sea is not just a geological site. It is a test of one of the most important questions a thinking species can ask, which is whether life is a common thing that the universe does whenever it gets the chance, or a fluke that happened once, here and nowhere else within reach. We do not know. That is the honest answer, and I am not going to pretend otherwise. We have not found life on Mars, and we have not found proof that it was ever there. But we have not found proof that it was not either, and that uncertainty is not emptiness. It is the most important open question in the exploration of the solar system. And here is why this channel, of all places, matters so much to that question. If microscopic life ever did exist in that ancient Martian water, then when the water retreated underground, and when the sediment settled on the floor of that vanished ocean, some trace of that life could have been buried with it, preserved, locked into the rock, the way fossils are locked into rock on Earth, the way the water itself was locked away and saved. And the best place to look for that trace is exactly the kind of place this channel leads to, the mouths of these floods, the floors of these ancient seas, the layered sediment where water once stood and life, if it was there, would have left its mark. This is also why the preservation matters so much, and why a place like the mouth of this channel is so precious. On Earth, evidence of the earliest life is incredibly hard to find, because our planet is relentlessly alive and restless. Plate tectonics drags old rock down and melts it. Wind and rain and rivers grind ancient surfaces away. Living things themselves churn through everything. Earth is constantly erasing its own past, recycling its surface, burying and destroying the record. Mars is the opposite. Mars, for all that it is a tragedy, is also the most patient archive in the solar system. With no plate tectonics to recycle it, no rain to wash it, no rivers to recut it, no life to disturb it, the Martian surface has held still for billions of years. A sediment laid down on the floor of that ancient ocean 3.5 billion years ago could still be sitting there, almost undisturbed, holding whatever it held when the water left. The very deadness that makes Mars so sad is what makes it such a perfect place to look for the traces of when it might have been alive. The planet froze its own crime scene and never touched it again. So when scientists send rovers to crawl across that surface, and when they plan missions to drill into the ground and one day bring Martian rock home, they are not just doing geology. They are reading the last pages of a story that the planet wrote 3.5 billion years ago and then sealed away. They are asking the channel what it carried. They are asking the buried water what it remembers, and it is a peculiar kind of conversation, the one we are having with this planet. Mars cannot speak, of course. It has no voice, no intention, no message it is choosing to send, and yet in every way that matters, it is communicating, because it has recorded its whole history in its surface and then preserved it perfectly, and all we have to do is learn the language. The scar is a sentence. The buried ice is a sentence. The shorelines and the deltas and the magnetized rock are all sentences, written across billions of years, waiting. We spent most of our history unable to read any of it, looking up at a red point of light and inventing stories about it. Now, finally, we have the instruments and the understanding to read what the planet actually wrote, and what it wrote is the most honest autobiography in the solar system, the complete account of how a living world becomes a dead one, set down by the world itself. And the answer, whichever way it comes, is going to be one of the most profound things our species has ever learned. If they find that the water was always sterile, that Mars had every ingredient and every opportunity and life still never began, then that tells us something sobering and lonely about how rare and fragile and improbable our own beginning may have been. And if they find that something did live in that ancient sea, that a second, separate spark of life ignited on the world right next door, and then died as the planet died, then we will know, for the first time, that we were never alone, and that the universe lets life begin and lets it end, even on worlds close enough to touch. Sit with both of those possibilities for a moment, because they are two of the heaviest thoughts a person can hold, and this one channel leads to both. Imagine learning that Mars was always sterile, that it had the water and the warmth and the time and life still never began, that the spark simply did not catch, even when every condition was met. That would tell us that the leap from chemistry to life is rarer and stranger than the speed of it on Earth makes it seem, that our own beginning may have been a near miracle, that we might be far more alone than we ever wanted to believe. And now imagine the opposite, learning that something did live there, that a separate and independent beginning of life took hold in that ancient ocean, completely apart from ours. That would be the single most important discovery in the history of our species, because it would mean that life is not a freak accident that happened once, but something the universe does whenever it gets the chance, on world after world, including one we can see with a backyard telescope. One answer makes the cosmos lonelier, the other makes it crowded, and the difference between them may be lying in the sediment at the bottom of a dry channel, waiting for a drill, waiting for a hand, waiting for us to come and read it. Either answer changes everything. Either answer reaches out of that scarred channel and touches the most personal question a person can ask, which is whether we are alone under our sky. It is strange and humbling to think that the answer to something so enormous, whether we are alone, might come not from staring out at distant galaxies, but from digging into the dirt of the planet next door. We tend to imagine that the great cosmic questions will be answered far away, out among the stars, in signals from other civilizations or in light from the edge of the universe. But the most important clue we have ever had access to might be sitting a short rocket ride away, in the frozen sediment at the bottom of a Martian channel, close enough that we could go and pick it up within the lifetime of people alive today. The biggest question in the sky may have a piece of its answer buried in the mud of a world we can already reach. And the channel we have been following all this time, that pale scar in the opening image, is one of the signposts pointing to exactly where to dig. And that is what I find so quietly staggering about that opening image, the pale wound running 1,300 kilometers across the face of Mars. When we started, it looked like damage, a scar, a record of a catastrophe, a planet that got hurt. But it is not only that, it is a message written in rock by water, sealed by cold, preserved by silence, and pointed directly at the places where the deepest answer might be hiding. The scar is not just where Mars was wounded, it is where Mars left the door open. A planet that had an ocean, and lost it, and hid the water, and maybe hid something far more precious along with it, has spent 3.5 billion years holding all of that in the dark, waiting. Mars is trying to tell us something, and we are only just now, after all this time, learning how to listen.